Good morning, sir. Myself, N. Devi. I am from ECE. My roll number is 234C180432. And today my topic is asynchronous sequential circuit design using Verilog. And the subject code is 23ECE303. First, we can go through the introduction to asynchronous sequential circuit. Asynchronous sequential circuits operate without a global clock signal. They rely on input signal to determine the state transitions. These circuits are often faster, can be more power efficient than synchronous designs. And key points of asynchronous circuits. The main components include state elements, combinational logic, and feedback paths. State elements can be flip-flops or latches that store information. Combinational logic determines the next state based on current inputs and states. And types of asynchronous circuits. There are two primary types: fundamental mode and pulse mode circuits. Fundamental mode circuits operates based on the stability of input signals, whereas pulse mode circuits use short duration pulse to control state changes. Next, we can go through the advantages of synchronous circuits. They can achieve higher speed due to the absence of clock skew. Power consumption can be lower as transitions occur only when needed. Asynchronous design can be more flexible in timing requirements. Challenges of asynchronous design. Design complexity increases due to the lack of global clock. Hazard and race condition can lead to unpredictable behavior. Verification and testing of asynchronous circuits can be more difficult. Verilog overview. Verilog is hardware description language used to model electronic systems. It allows designers to specify the behavior and structure of circuits. Verilog is widely used in both synchronous and asynchronous circuit design. Modeling asynchronous circuits in Verilog. First, asynchronous circuits can be modeled using continuous assignments and always blocks. Combinational logic can be represented with assigned statements for outputs. State changes should be defined within always block triggered by output changes. State transition diagrams. State transition diagram visually represents the states and transmissions of a circuit. They help in understanding the behavior of asynchronous circuits. Each state represents a unique condition and is likely linked by transition based on outputs or inputs. Designing a simple asynchronous circuits. Begin by defining the required state and transition in a diagram. Write the Verilog code to represent the state transition and outputs. Simulate the design to verify the exit behavior before implementation. Using FSMs using finite state missions. Finite state mission is a common approach to modeling asynchronous sequential circuits. They consist of states, inputs and outputs along with the transition logic. Verilog provides constructs to simplify FSM design and implementation. Handling race conditions. Race conditions occur when the timing of events causes unexpected behavior. Properly designing feedback paths and using stable states can mitigate issues. Verilog allows for the implementation of instability handling techniques. Next, simulation and verification. Simulation is crucial for Verilog verifying the functionality of asynchronous circuits. Test benches in Verilog can be created to check various scenarios and edge cases. Tools like ModelSim or Vivado can be used to simulate and analyze the design. Optimization techniques. Circuit optimization can reduce power consumption and improve speed. Techniques include minimization, logic levels and consolidation. State transition. Verilog allows for primitive size designs that can be tailored for performance. Real world applications. Asynchronous circuits are commonly used in communication systems. They are also found in low power design for portable devices. Other applications include design signal processing and control systems. Conclusion for future trends. Asynchronous sequential circuits offer unique advantages for specific application. With advancements in design tools and methodologies, they are gaining popularity. Future research may focus on improving robustness and ease of design using Verilog. Thank you, sir.